class. Um, what is quantizations? What is the diversity and channel encodings? We'll see. Before this, what is the fundamental of the quantization? AMS. In the last class, we already said that this is the first technology in the cellular communications, mobile communication in the today world. Also, this coming up, those 3G, 4G, 5G, all those things come from this AMS. This is the technology implemented in the mobile communications. So it is the standard that analog signal cellular phone services in the United States and is also used in other countries. Also, it based on the initial electromagnetic radiation spectrums. So this is based on the analog. Okay, it's not the digital communications. This is the analog communications. But now today we are using this digital communication only in this cellular technology. But in the recent year, it uses this analog communications. Okay, analog signals. I hope that you already know that the difference of these analog signals and digital signals. Analog is very much complex as compared to this digital communications. There's lots of errors, chance of errors in the communications in the analogs. Okay, analog types of communications, but digital is very simple and errorless. Chance of error is very less as compared to this digital analog communications, and also is very easy to implement in the digital communications. Encryption, decryptions, and encoding and decoding of the communication is very easy in this digital communications. Okay, it is based on the initial electromagnetic radiations. This AMS is based on this electromagnetic radiation spectrum allocations for cellular services for FCC. This is the US government, federal. In US we say that government is federal. Okay, Federal Communications Commissions. In India we have Ministry of Communications and Electronics, our ministry, MIT ministry we are saying, but in US they say that this federal communications commissions in 1970. Okay, in 1970, introduced by the AT&T. This is the one of the company or one of the department under the FCC, Federal Communications Commission. AT&T, it's like a BSNL in US. 1983, AMS becomes one of the most widely developed cellular system in the United States. Okay, these are the history of the AMS and how it's used in the equalizer. Okay, so generic adaptive equalizer. So how we are in a training mode. So these adaptive equalizers, initially known as fixed length training sequence, is sent by the transmitters. So for these equalizers, adaptive equalizers, we have to have a training sequence. To know the sequence of this spectrum and all, we have to train the transmitter. We have to send it. Okay, so that the receiver equalizer may average to proper settings. Okay, average proper setting. The training sequence is a pseudo random signals for a fixed prescribed bit pattern. Immediately following the training sequence, the user data is sent. So initially in the training mode of this adaptive equalizers send out the fixed length training sequence in the pseudo code in the random signals or a fix. This is called the prescribed in the bit pattern. Okay, immediately following that the training sequence and the user data is sent. Okay, training sequence is designed to permit an equalizers. Okay, training sequence. Training sequence is designed to permit an equalizer and the receiver at the receivers. Okay, at the receiving end, it's send the training sequence to the receiver side, and this is designed to permit an equalizers at the receiving end to acquire a proper filter and coefficients in the worst possible channels conditions. So there are some conditions, there are different types of conditions in the receiving channels. Maybe a worst case, okay, maybe a best case. So these will acquire the proper filter coefficients in different conditions. Therefore, when the training sequence is finished, uh, therefore filter coefficients is near their optimal value of receptions of the data, sorry, user data. First, it's training sequence. So equalizer, adaptive equalizer, generic adaptive equalizers, uh, what is doing? The first thing is the training mode. Okay, in this training mode there are two types. Okay, there are two types, we can say that there are two types of processing in this. So the first process is that training sequence is a pseudocode. Okay, is a pseudocode random signals or fix prescribed in a bit pattern immediately following the training sequence, the user data. Okay, the user data. So for doing so, we need to have those permit equalizer to add receivers to acquire the proper filter coefficients in the worst possible channel conditions. Therefore, when the training sequence is finished, okay, these filter coefficients are near their optimal value for the receptions of the user data. Okay, reception of the user data is needed to sense after this training mode, training sequence. An adaptive equalizer at the receiver uses the recursive algorithm to evaluate the channels and estimate filter coefficients and compensate for the channels. Okay, after those things, then adaptive equalizers of the adaptive equalizer at the receiver end use a recursive algorithm to evaluate the channels. So there are different types of channels from the receiver side. Okay, so it's evaluate the channels and estimate the filter coefficients in the recursive mode to compensate the channel. And okay, so these are the things in this generic adaptive equalizer. And let's go to the rec receivers. What is a rec receiver in these quantizations? Let's see. The rec receiver consists of multiple correlators. So multiple correlators in which the receiver signals is multiplied by time shift version. Okay, time shift version. So in the rec server, we have a multiple correlators. So these multiple correlators in which the receiver signals, the receiving signal, the transmitting signal send the informations. Okay, so the rec server consists of the following: this multiple correlators in which the receiver signals is multiplied by the time shift versions of a locally generated sequence. Okay, this code is generated based on the multiplied time shift. Time shift means each and every multiple correlators having the time shift. Okay, and those time shifts are locally generated. Okay, locally generated code sequence. So the intention is to separate signals. So we have to separate the spectrum, signal spectrum. okay, signal spectrums such that each finger only sees, okay, each finger only sees signal coming in over a single path. So there are different types of multiple correlator shift time shift versions. These time shift versions in the rec server, time shift server in the rec server. So that code is chosen to have a very small autocorrelations valued for any non-zero times offset. This avoids crosstalk between fingers. In practice, the situation is less ideal. Okay, in practice, the situation is less ideal. It is not the full periodic autocorrelations that determine the crosstalk between signal in different finger, but rather two partial correlations with contributions from two consecutive bits or symbols. So it has attempted to find sequence that have satisfactorily partial correlations values, but the crosstalk due to partial, well, when you say this crosstalk, there are interference. Okay, crosstalk means there are interference between this correlator. Okay, there are in the frequency spectrums we have to send different types of signals, electromagnetic spectrums. Then in between this we have a crosstalk. Okay, crosstalk correlations remains substantial, more difficult to reduce than the effect of periodic correlations. So what is the rec server? The rec servers, the rec receivers. What is the rec receivers? A rec receiver consists of those multiple correlators. Then in the receiving end, this signal is multiplied by the times shift versions of a locally generated code sequence. So these are the things in this rec server, rec receivers. Okay, rec receivers. And we can move on to this interleaving. Okay, what is interleavings? Interleaving is a tool that is used to enhance existing error code so that they can be used to perform burst error corrections as well. Okay, burst correction as well. This is the tools to boost up or to make it good performance during the time of the communications, and also existing error corrections codes so that they can be used to perform this burst error. Okay, I don't know that you already learned this error detections and error. I'm not sure in your previous subjects if you cover or not this error correction and detection mechanism. In zero time, error correction and detection. Error correction le detection ka in zero time. Hello.
Sir, zero machine.
Error correction and detection mechanism acuan ang lo in 0 to m OSI reference model. Computer
Zero machine, sir.
Okay. In the zero son claim kan silo ko nga error correction and detection mechanism acuan communication na reng chuan by chance til tam tak chance om thei. There's lots of chance of errors in the digital communication and also in the analog communication also. So if there are some error in between the communication, say suppose I'm user data, user informations from one system, from one computer to another computer, or maybe another one device to another device. In between this there is lots of chance of errors. Okay, chance of errors means there's lots of attenuations and noise. Okay, and distortions. There's a chance of things are there. So if there are some error in between the communications, that at the receiving end we have to take actions, okay, regarding this receiving data, receiving data. Then there's in this first in this error, the chances for burst error and single bit errors. Okay, if it is single bit error, single bit means we can have binary communications. Sorry, in this digital communications, we can send binary numbers. Okay, in this binary, if we send these binary numbers, single bit error means if there are some changes in only one bit. Okay, if one is changed to uh, 0. Okay, let's see here. Let me show you this. Where is it? Inside shapes. Okay. So suppose I'm sending this 10100. Sorry, 01. Okay, I'm sending to the communication channel. Then at the receiving end, 1010, and 1 is coming, 01. Okay, this bit is changed. This 0 is changed to 1 here. Okay, in the communication channels, if I'm transmit this one from R, from T to transmitter to the RX, receiving X. Okay, RX. So if it receives this one, this binary number, then there are some error. Okay, there's some error in this communication channel. Okay, there are some error in the communication channel. The thing is that in the in the channels, maybe some electronics part or any other some electromagnetic interference, its chance are there. Okay, chance are there to change the binary informations. So this is called the single bit error. But these single bit errors, we can correct it by using this some mechanism. And if it's changed this value, if it's become 1 again here, then it's changed more than 1 bit. Okay, more than 1 bit, then this is called burst error. If it is more than 1 bit, or maybe here it's changed this value 1 to 0 again. Okay, 0 again. So error come in this last 3 value. Okay, in this last 3 values, then this is called burst. If it is more than 1, then we say that this burst error. If the all bits are changed to the opposite number, then this is called also a burst error. Okay, so this is used to perform burst error correction as well, means it's having the error correction mechanism at the end in this interleaving. Okay, interleavings having the mechanism to how to say this mechanism to correct the error. Okay, most error corrections code ECC are designed to correct random error. So random error means maybe here is not the random error. 001 is changed to this 110, means it is the sequence. Okay, it's changed in the sequence. But if it is random error, if there is bit change at the beginning, okay, at the beginning of the binary, okay, at the beginning of binary or at the end of the binary, then this is not a sequence, this is not changed in sequence, it's changed in the random value. This also very difficult to detect the error and also correcting the error. Okay, detection and correcting is complex in this random change. Okay, so this interleaving, okay, these interleavings are designed to correct this random error also, not in this sequence bus. Sequence bus means in data error om khan mo in data error chu tem chon asiam ala ola ni detection error mechanism chuanin tema in dot thlapa error om kha chon khak ting hu ka chu error correction ka alazia amaro chu khatiang angchi in dot thlapa i ron om si lowa mo error om si lowa i ein kar hlat dewa error rom kal khan khating chi kha ala complex ema mar chu interleaving hian this random error ang chi kha ni correct thei ti nani tani correction random error kan ti kha error a hianin kha ka soita kan khan single bit error om thea burst error om thei boka chuan random mo burst ani rual si khan random le sequence in om thei ti nan tani le okay. That is error caused by this adaptive noise. That is adaptive noise that depend on each others. Okay, that depends on each other. This adaptive noise. There can be a noise, or maybe there can be a disturbance in this attenuations, loss of signals. Okay. Noise that is depends on each others, that noise that depends on each others. Burst errors are the errors that occur in a sequence or as a group, okay, that burst having this group of error, not in an random sequence. They are caused due to the defect in a storage media or disturbed in the communication channel due to the external force like lightning strike, or maybe a spike, or maybe any high tension current or anything can cause this type of error. Interleaving modifies this ECC. Okay, ECC means error correcting codes, ECC, or does some processing on this data after they are encoded by the SEC. Okay, so ECC. So this interleaving modifies. Okay, this interleaving modifies those things. What are the things in the interleaving? Modifies those important point. Modifies the error correcting code or some processing of the data after they are encoded by the ECC. Okay, error correcting code. I hope that you clear this interleaving. So let's see the example of this interleaving. Suppose there are certain error detection code, okay, error detection system are generated. The 4 code what, okay, 4 code what, we have this sequence of binary number in a 4 blocks. The following diagrams illustrate the interleaving procedures. Okay, so these four forward sent from the sender to the receiver, and then this burst errors are there, and how those things are detected using these interleaving systems. This graphics depicts those things here in this interleaving code words. Okay, code word, interleaving code word sent to the communicational channel. At the receiving end, it receives some burst error. Okay, it's receiving the burst error. Interleaving, we can say that those things, the first, okay, and the first is taking out all the least significant bit of this code word, taking out and sent to the communication channel. The first least significant bit is all the first bit. Okay, and send it here, and the yellow, all those yellow second bit. Okay, third bit. Okay, those. And in the communications there are some error in this. There are some error in the burst. Okay, at the receiving end, if there are some burst here, then here this is an error in this 4 bit. Okay, it's changed the bit here, it's changed the bit, it bursts here. So at the receiving, all each and every code word is arranged from the least significant bit, starting from the leftmost side, and it's goes to the right side. Okay, okay, those are the things. What is rake receivers, we already explained, and then what is the equalizer and what is the interleavings, we already explained those things. And let's move on to the fundamental of channel encoding. Channel encoding is often used in digital communication systems to protect the digital informations from noise and interference and reduce number of bit errors. So we have to encode all each and every channels of communication. If we say this channel, that in our local TV also, in the local transmitting also, we have a channel. Okay, channel, we can control, we can view those channel using our remote control. Each and every channels having the channel number, channel number ones, what we are tuning, channel number two, what we are tuning. Based on this tuning, then we can view the informations. Okay, we can view the informations. Okay, like this in the telecommunication telecommunication system also, we have a channel. Okay, we have a different types of channel to connect more than one users in this in the cellular network. Okay, more than one users in the cellular network systems. Okay, cellular communication system. Okay, and then this channel, we have to protect, we have to protect each and every channel from what, from noise and interference. One channel can interfere to it create problems to another channels. Okay, one channels can create a problem to another channel. So to protect it, to protecting those channel communications, then we need to have encryptions and decryptions for this. Okay, in the digital communications. Okay, analog communications, in analog communications, or it's very more complex than the digital communications. Okay, let's see. uh, let's see more in this channel encoding. Channel encoding is more accomplished, mostly accomplished by selective introducing redundant bit into a transmitted information. So redundant means unnecessary informations, unnecessary bit, redundant, extra bit, we can say redundant, into a transmitted informations. These additional bits will allow detections and corrections of bit error in this received data stream and provide more reliable information transmissions. The cost of using channel encoding to protect the informations in a redundant in data rate and expansion in the bandwidth. Okay, so it can expand the bandwidth also, and it's used for reducing data rate. Okay, reducing the data rate for what? There are some redundant informations due to some interference and noise. Okay, it can add up the more informations in the communication channel. Okay. What are the different types of channel encoding? Let's see here. There are two types of channel encoding, namely block code and convolutional code. Mistake. Let's see the block code. Block code are based rigorously on finite field arithmetic. Okay, finite and infinite. Okay, there are two types of mathematical calculations: infinite and finite arithmetics. These block code are based on this rigorously on finite field arithmetics and infinite field arithmetics. Using this finite arithmetics and abstract algebra, they can be used to either detect or corrections. Okay, so we can correct the errors, and also we can detect the error also. First, detects. Only detections is available in this communication channels, but after detecting, there are chance of corrections also. Corrections and detect the correction and detections. Okay. Block code accept the block of k informations bit and produce a block of n code bit. So these block codes accept block of n informations. We have a block of values. Say suppose here we have a code what. So this is the block. Okay, this code what is a block. Okay, so each and every block of k informations. K means information bit. Okay, information bit, and produce the block of n codes. So it produce the block of n code bits. Okay, this and every block have n code bit by predetermined rules. N minus k redundant bit are added to the k informations bit to form the n code bit. Commonly, these codes are referred as n, k block code. Some of the commonly used block code are the humming code. Okay. In this humming code, let me show you this humming. Let's see here. Okay, in this humming code error detections, where it's having the error detections here, 7-bit humming codes is the code used to send the data along with this code. Okay, let's see here. We have in this 7-bit code humming, is divided into the data bit and the parity bit. What is this parity bit? Parity, we can say this for checking the single bit error. Okay, single bit burst. Sorry, single bit error, not the burst. Single bit error, for checking this single bit error. So if we are using this parity, even or odd parity, let me explain this. If we send this parity bit 101101, okay, if P is even, okay, even parity, even parity, so we have to send one more bit here extra. Okay, here E, this is for the extra bit here. This is the original data, then we have to send one more bit here. This is the extra bit for the parity. Okay, if we consider this even parity, let's count the number of let's count the number of this one. Okay, 1 2 3 4. The number of 1 is 4. 4 is even number. Okay, so it's still the even number, the number of ones. Then here we have to add this value 0. Why? If it is this even parity, okay, if it is this even parity, okay, okay, let me show you like this. This is this it's more clear. This is the parity bit. Okay, this is the parity bit, and sorry, and this is the okay, this is the data bit. Okay, this is the parity bit. So if we consider this even parity bit, this number of count of 1 is 1 2 3 4. 4 is the number of ones in this data bit. Then no need to make it even. Okay, it's still 1 is still even, then here we have to put 0. But number of data sent is this one. If it is 100,101, if the data is this value, then let's count this parity, sorry, number of 1 here, 1 2 3. So this is 3. Okay, number of ones in this database is 3. So to make it even, then here we have to put this, we have to put this one. Okay, I hope that you clear this one. Then let's see at the receiving end. Okay, it received this data 100. Okay, 1000. It's changed here the data, it's changed the informations here. 0 0 1 1. Okay, 0 0 1 1, and sorry, okay, this is the data, and here this is the parity. Okay, parity bit. So at the receiving end, it's count the number of 1. Okay, the number of 1. But see here, the number of 1 in this digital the data block is 1 2, and here still 1 is coming here, then is coming out again. Okay, so there are some bit burst. Okay, there are some bit error in this. Okay, this is called the parity. So see here, in this humming error detections, it's having this data bit 4 and parity bit 3. If you sum up this one, then it will come 7. Okay, this is 7-bit code. So in this 7-bit code, we have a data field and parity field. So this is data. Okay, this is data, this is data, this is data, this is data, and this is parity, this is parity, this is parity. So each and every parity bit controls some data. Then here, let's see, this, okay, it's not possible to enlarge. So P1 parity 1, this parity 1 control this data block 3, 5 and 7. Okay, parity 2 control this D3, D6 and D7, and parity 4 control this D5, D6 and D7. So each and every data blocks controlled by this parity. Okay, so there are many ways to detect the block code and estimated the cat information bit. Those decoding techniques will be discussed here, but can be studied in a course of coding theory. So we can study it in the coding theory, and those commonly used code are referred to as K and NNK. So NNK blocked, okay, block code. Some commonly used block code are the humming code, I already explained. Then Collet code also, BAC code also, red salmon code also there. Okay, so this using this cat big code of the data block code. Okay, so we'll end up to this, and we'll continue this class in next week. Okay, so that's all for today. Let me call your roll number. Roll number 2, Krishna.
Present, sir. Present, sir.
Roll number 4, roll number 5,
Present, sir.
7,
Present, sir.
8, 9,
Present, sir.
10, 11,
Yes, sir.
12, 13,
Present, sir.
14, 15,
Sir, row number 4 present.